Okay, so today we are going to discuss about integration and differentiation. So before moving into that, let's understand first differentiation. So what is differentiation? So let first of all we'll understand about what is constant quantity. Constant quantity. So what do you understand by the constant quantity? We will say in term the value that remains same. So those value that remain same is known as the constant quantity. Constant quantity. So for example, we have an integer. Let's take an example. What is the constant value? So we have an integer value 1 2 3 4 up to the n. So all these are the constant value. If we will talk about the fraction value like 1 upon 2, 5 upon 4, so this is constant values. We have the value of pi, that pi is constant, value of e is constant. So these are an example of the constant quantities. So now we will be discuss about variable quantity. So what exactly the variable quantity is? So in variable quantity we will come into the variable quantity. Understand? Any doubt from the constant? What do you understand by constant? Now we will discuss about variable quantity. So in variable quantity, the quantity takes a different value when we do the mathematical operations. So that is known as a variable quantity. For example, we will say y is equal to mx plus c. So this is an equation of a equation of a line, y is equal to mx plus c. So let's consider this is a point. Here we have x is equal to 1. Okay, and this c is the slope. So what we will consider here, we will say here y is equal to I'm just taking here value m. This value of x is m plus c. So if I put this value m plus c, so this is the this will be my value. If value of x is equal to 2, if I will say x is equal to 2, then y is equal to 2m plus c. So when we will substitute this value of m and c, so we will get the result. Okay, so this is the this quantity here. This quantity is a variable quantity. Variable quantity. So why it is variable? It depending on the value of this x. This quantity is depends on the value of x. So that's why we will say this quantity as a variable quantity, this x as a variable quantity, y as a variable quantity. Okay, so same way we can take another example like F is equal to m into a, force is equal to mass into acceleration. So this force will be a variable quantity where we have some value of mass and some value of acceleration here. So variable quantity is divided into two parts. So this variable quantity, we will have two things. One is the dependent variable and another one is independent variable. So here we have independent variable, another is dependent variable. So what is independent variable in this one? So if we will say force is equal to mass into acceleration, or if I just write an equation y is equal to 3x plus 4. If I am writing this equation, so let's take an example of this equation. If I have this equation, okay, in this equation, if I will say what is my independent variable and dependent variable. So in this equation x, if I'm talking about this equation, x is an independent variable, and if I will put the value of x, the value of y will be changed. If I put the value of x is equal to 1, so this is equal to 7. When x is equal to 1, okay, when x is equal to 2, the value of y will be 6 plus 4 is 10. So this y will be the dependent variable. So we will say that this variable quantity is divided into two parts, correct? Any doubt in this one? Okay. So now another terms come into the picture, that is function. So what is a function? Let's understand the definition of a function in simple words. We have a let's consider a given value. We have a given value of x. For a given value of x, there exists a single function is not single, a single definition of single defined value of single definite value of y. Then we can say that y is a function of x. So when we'll say this one, y is equal to fx, this is the denotation of the function. So y is equal to fx we will write. So let's take an example to understand it more better way. We'll take an example here. So here what we did, this is the that we are going to explain. This is our function that we are defining over here. So this is the function here. Okay, so now when we discuss about this one example of this function, so we'll take examples of this function. So example of this function is, if I am just writing here y is equal to like 5x. So when here x is equal to, I am just taking here 2 here, so the value of y will be here 10. When I am substituting, so let's take here x and y. When I substitute value y, the value of is 10. When I am substituting 3, the value of y will be 15. Any doubt till this point? Okay, so if I consider here 4, this will be 20. So these are the value when I substitute x and y, this 2, 10, 3 and 15. So these are the value over here. So now what is the conclusion from this one? So this one we will define that the value of y. So here this fx is the, what is the value of fx? Fx is equal to 5x. So this value of x is equal to whatever the value that we are substitution here. So now we'll come into the difference and the differential coefficients here. So we will say here y is equal to, y is a function that is of fx. So this is a function where x and y are variables. Okay, let's consider there will be a change in the x. Change in x. So that is denoted by, change in x is denoted by like this one. So when we say x plus delta x, so this will be the change in the x. So that will be defined as the change in the value of x. So now what will be the value of y? So like we will write y is equal to, when I write here y is equal to, I am writing over y is equal to we have x over here. So if there is any change in this one, so this y will be x plus delta x. Okay, so if this is my equation first and this is my equation second, if these are the two equations, so we want to find what exactly the change in y. So delta y, if this is y1 and this is y2, delta y is equal to y2 minus y1. So what is the value of y is equal to x plus delta x minus x. So this value will be, we can cut this value. So the remaining value is delta x. So the rate of change of, so the difference here, so I just want to show the difference. So the difference here is, so difference here is delta x and difference in the y is delta y, correct? So now come into the conclusive point, the ratio of, like I am just writing here, delta y upon delta x. Okay, this is the value that I am writing here. So this is called the quotient of the two incremented values. So when the difference of delta x and delta y is very small, so we can write it's equal to the dy upon dx. We can write it like dy upon dx, and this difference is very rare. So let's take an example over here. So this is the value of x, and there will be very small change over here. Okay, so that change we are representing it with the help of delta x and delta y in the axis of x-axis and the y-axis. So we are denoting this with the help of delta y upon delta x. Okay, so now come into the, so what till this point, let's have a recap of what we discussed. So right now what we discussed, we understand about what is constant, these are the constant values. So now after that we understand about variable quantities. What are the variable quantities? Variable quantities have two things. One is the dependent variable, another one is the one is dependent, another is dependent. So if I write an equation, y is equal to 3x upon 4, here x is a dependent variable and y is a independent variable. Okay, so then we discuss about function. So function is equal to y is equal to fx is a function. When we substitute the value of x, the value of y, we can derive it. Okay, then we find the change in the change in x and the change in the y. So that we denote, there will be the quotient of y upon divided by x. So we will get the dy by dx. So now we understand about the limits one. So in mathematics, when we come into, so this change, so let's understand this limit. So we will write here limit of delta y upon delta x. So where delta x is not equal to 0, it's near to 0. How we will write it? So when we set this one, so this delta, what we try to represent over here, we try to represent that this equation, whatever the equation that we are going to write, understand this equation, this is equal to limit. So sometime we will write it like LT also, where delta x tends to 0, it's near to 0, divided by dy by delta of this one, delta y upon delta x, and this is equal always represented by dy upon dx also. Okay, so what we try to say, the ratio of delta y upon delta x is a very small quantity, where delta y is another small quantity and another small quantity, then we will say that dy upon dx is the differential coefficient of y with respect to the x. So whatever we write it, what it means, it is a differential coefficient of, what it means, it's a differential coefficient of y with respect of x. Okay, so now we'll come into one more form of equation over here. We'll write here dy upon dx, that is equal to limit of delta x tends to 0, where delta y upon delta x, and this is equal to limit of delta x tends to 0, where we are writing in form of functions. So where we have a function where x plus delta x, so we said na, a function there will be small change, minus function of fx divided by delta x. So this is known, this is form of in form of limits. Okay, so now we'll understand about differentiation. Now what exactly the differentiation is. So till this point what we did, what we try to understand the terms that will be going to helpful for the understanding of differentiation. So differentiation, the process of finding the differential coefficient of a function is called the differentiation. So now come to the definition of differentiation is, this is the differential coefficient. This is the differential coefficient. Differential coefficient of a function called differentiation. Okay, so let's discuss about the some theorems of differentiation, then we will come into some more forms. So first is, this is the point that is come into the picture, derivation of a or differentiation of a, we'll say differentiation of a constant is differentiation of constant. So the differentiation of a constant is 0. When we write here d upon, so let's say dy upon dx, so this is the differentiation. Here if I want to differentiation of a pi value upon x, so the result will be 0, because we know this pi, whatever the value that of that we are writing over here, this pi 1, so this pi is the, what we are trying to say here, this pi that we are going to represent, this is the constant value. So this is the constant, so this is why the differentiation of this one is 0. Okay, so now come to the another point, the second point. The second point is the differentiation of a coefficient of x की power n. So like now I have the value x upon n. What we have to do, we have a function, so having the, but we have a value of x की power n. So what we have to do, we have to find the differentiation of y is equal to x to the power n. So how we will find, so dy upon dx is equal to, so value of dx की power n upon dx. So the formula for this one is, this is equal to n x की power n minus 1. So what we try to represent over here, so this is the formula for this one. So the derivation for if any function we will writing like this one, so the formula that will be representing over here, so this will be the formula for this one. Differentiation for x की power n, we have n over here, x n minus 1. So these are the important formulas that we are going to discuss. So third point, so third formula that we are going to discuss is, so the third formula is here, the differentiation of an algebraic sum of two functions. So like we have I have a function y is equal to, like I write here, this is u plus minus v plus minus w. Same way we have n number of addition multiplications will be there. And what another point is, u, v and w are function of x. This is important point, these are the function of x. So let me just write it correctly, sorry I missed this point. So what we said here, u, this is the u, v and w are function of x. So this is the important point that I want to highlight over here. So now we want to find the differentiation of these functions. So how we will do? We will do dy upon dx. So here d upon dx of u plus minus v plus minus w plus minus up to the number. So how we will do this one? So we'll split. So the point that I want to be raise here. So how we will do? We can write this as d upon u upon dx plus d upon v upon dx plus d upon w upon dx plus minus up to whatever the values we have writing over here. So how we will do? If it will be plus minus, so we can write over plus minus over whatever the symbol over there. So these are the three basically basic theorems of, you can say, basic theorems of differentiation. Let's have a recap. So the recap point I want to tell you here. So the recap point is, the first point, the differentiation of a constant is 0. After that, the second point, the differentiation of x to the power n is n x to the power n minus 1. The next one is the, basically we have the function, algebraical functions, and how we will do that sum. So this is the way how we will do. Okay, so now we will come into the rules of differentiation. Now before moving into this one, we will have rules of differentiation. So what are the rules over here? Rules of differentiation. So the first rule is product rule. First is product rule. So what is product rule? Product rule is, I have a function y is equal to u and v. Okay, these are the two functions where u and v are function of x. U and v are the function of x. So we have to find the derivation of this one. So dy upon dx is equal to d upon dx u and v. So this is u and v. So we can write it like, first we'll take the u as a common, derivation of v upon dx. Then we will take v as a common, d u upon dx. So the point that, the formula that I want to, we will take as a common v and u, and after that we will do the differentiation of this one, dv upon dx and du upon dx. Okay, so finally when we will do this one, so the finally when we do this one, so this will be the formula for the product rule. Okay, so what we understood, we first now we'll consider what is the product rule. So the product rule, we have y is equal to ux, where these are the function of x, and when we do the differentiation of dy upon dx, this is equal to this one. Any question till now? So now another formula will be the quotient rule. Second rule will be the quotient rule. Quotient rule. So what do you understand by the quotient rule? So like I have a function, now this is in the form of u upon v. Okay, where u and same way where u and v are function of x. Okay, so in this case how we will do that? We will do dy upon dx is equal to d upon dx of u upon v. So the formula is very interesting over here. First of all, what we will do, we'll take here common v and write here du upon dx. Then minus, we will take common here u, then we will write here du upon dx divided by divided by whatever the v square. Okay, so this is the quotient rule that we discuss. So the quotient is when we have this one u upon v. But first of all, what we will do, we'll apply that quotient, this one denominator as first, and differentiation of du upon dx, then minus symbol. This is the numerator and differentiation of v. So here I have to write here v. So this is v here, not u, dv. So the point is write here numerator and differentiation of denominator, and divided by its a v square. V square is what is our denominator square. Okay, so this is the what we discuss. We discuss about the quotient rule. Now we will move into the chain rules. Let's come to the next formula, or we can say next rule. That is the third rule is chain rule. So chain rule we will have here. So in chain rule, let's we have a function f is equal to u upon v, where u and v are two function of x. We have the two function of fx. So how we will write the chain rule? We'll write here dy upon dx is equal to, first we will do dy upon du multiply by du upon dx. So now what exactly the difference here? The difference here we have f u upon v. Okay, dy upon dx. What we did, dy upon, first we will do dy upon du, sorry, not u, dy upon du. This is du, and then du upon dx. Then what we did, du upon dx. So we will get the dy upon du. So this u comes from here, this u comes from here, then this u and this u. Okay, so what we did, so this is the formula for our this one chain rule. This is the chain rule. Okay, so now come to the another formula. So now the formulas that come into picture, that will be the differentiation in form of theta. Okay, so you heard about sine theta, cos theta, tangent theta. So how we will do that? So there will be the trigonometric functions here. So today we are going to discuss about basic trigonometrical function. Basic trigonometric function means we have sine theta. So now we have d upon dx of sine theta, sine x we can say, because whatever we are discussing in the form of function x. Okay, so the formula for this sine theta is the reverse of this one. The reverse of this one is cos x. This is the first formula. Second formula is d upon dx of cos x. So this is equal to minus sine x. Third one is d upon dx of tangent x is equal to secant square x. So one more point, how these formulas we derived. Okay, so let's take an example of let's come into the derivation of this one, otherwise you will forget. So we have a formula over here, sine square theta plus cos square theta is equal to 1. So this is the formula that we have, we will write. Okay, so how we will derive this formula d by dx is equal to cos x. Have you understand this point? Okay, one second, let me first tell you the basic formula forms, then I'll come into this part. Maybe it's little bit early. Okay, so this is equal to secant square x. Then the fourth one is, we will have d by dx of cot x, that is equal to minus cosecant square x. Then the fifth formula for here is d upon dx of secant x, sec x that we say, is equal to secant x into tangent x. And the last and formula for this one, basic one, is d upon dx of cosecant x is equal to minus cosecant x into cot x. So what we discussed, these are the basic formulas for the differentiation. So why we are saying these are the basic formulas? Because based on that we will derive many equations and many more complex differentiation. Based on that, to proceed with that, you should have these basics formulas in your mind. Then after you can start with that. So before proceeding into integration, what we will do, we will solve few examples so that we can have the hands-on on these questions. So let's take an example of, now what we are going to do, we are going to solve the questions. So let's take the question first. First question is, solve this question, y is equal to, we have right here 2x plus 3. Okay, so then you have to find the value of, you have to find the differentiation of this. You have to find the differentiation of dy upon dx of this function. So how we will solve this? Let's whatever the formulas that we have done, we'll use that formulas. What we will do, dy upon dx is equal to d upon dx. We have the function is 2x plus 3. The formula that we will apply over here, that is, let's discuss about this. The first, you remember that the formula that we discuss over here, that is not chain formula. So first what we do, we will apply the chain formula. Chain formula, why? Because we have the here. So what we will write here, d upon dx of 2x plus 3, d upon dx of 3. So now we'll apply the formula for this one. Now let's see, let's keep focus on this one. So first of all, see, this 3 is what? This is constant. So the differentiation of a constant is 0. So what we can do here, we will write over here d upon we will write over, change the pen over here. So we will write here d upon dx of 2x. Okay, so let's come here. So 2 is constant, so we'll take it outside, d by dx of x. Okay, so now keep focus on this one. What we will do, this we will have this formula here. So you remember that we have taken one formula. The formula is here x to the power n. Okay, and we did d by dx of this one. So this is equal to n x n minus x minus 1. So the same formula that we are going to apply over here. So how we will be apply here, this is equal to 2. We'll take here 2. The value of x here, it is 1. Okay, so with this formula, what 1 will come here, x here 1 minus 1. So we will know 2 into 1, this x to the power 0. So when we solve this one, any power of 0, we know x to the power 0 is equal to 1. So 2 into 1 into 1, so this is equal to 2. So what we try to solve here, the differentiation of this one is equal to 2. When we solve this one, so the differentiation of this function is 2. Let's take another example over here. This is the I'm talking about arithmetical one. I am taking here d by dx of what we have, differentiation of what we have to find. We have to find x की power 3 minus 4x square plus 3. Okay, we have to find the differentiation of this one. So to solve this one, what we do, let's take the example this one. So what we have to do, we have to find the differentiation of dy upon dx of this function. So this dy upon dx is equal to, first we will split it, d upon x to the power 3 upon dx. Okay, and then we will have here minus. So we'll write minus d upon dx of 4x3 plus d upon dx upon 3. So see here what we're trying to see. So this one is the constant here. So we know the value of the constant will be 0. Then we will apply the formula for this one. The formula, what is the formula that we are going to use here? The formula that we are going to use for this one is, we know x to the power n. The differentiation of this one is equal to n into x power n minus 1. So we'll solve this one. 3 will come here. X 3 minus 1 minus 4 into 3 into x to the power 3 minus 1. So when we solve this one, so this will be 3 into x square minus 12 x to the square. So this is the differentiation of dy upon dx. So this is the formula that we trying to solve this question for the above one. Got it? So this is the examples that we do the practice. So you can I will give you more examples for the practice, so you can consider. One more last small question that just to understand and to recap the things. Tell me, what is the differentiation of d upon dx of a pi? Tell me.
180.
Which one?
180.
No. In terms of circle, that when we draw the circle, if we're talking about this angle theta, this one, then it will be 180. But here this pi, initially I told this, what is this pi? Pi is the
22 is it?
Constant.
Constant.
This pi is constant. So any value of a constant, it will always be 0. So any constant, the differentiation of any constant, the result is always 0. Okay, so it's just to understand what you learn. But okay, so we will end up the differentiation part till here. I will give you 40 questions for the exercise to have a practice for this differentiation. Tomorrow we'll solve that 40 questions. Okay, so we'll wind up the today's session. Okay.